And sure, let's just get cracking. Okay. All right. So, onto the presentation. Okay. So, what are we going to cover this week? I'm going to cover something that I kind of missed in some of the previous weeks, is like, which is basically, once you have a 3D printer, what is the care and feeding involved with doing with having one? I'm going to talk a little bit about finishing prints. So all the sanding and painting, and all the fun stuff that you get basically once you've created a print. I'm going to touch briefly on 3D packages again and CAD packages. And I'm also going to do, I'll save a little bit of time at the end for sort of like general questions, just in case you have any. Okay. So yeah, it should be pretty straightforward. But before we get onto that, I think one of the things that I want to briefly go over is just following up from last week in terms of printing in place, right? So last week I was thinking quite a lot about the printing in place thing, and like what it takes to practically make that happen. And I wanted to show an update to a particular model that I've been working on, which is basically trying to make I guess if you like, a walker, right? So I've been working on this particular design, which is based on the design of a Dutch artist called Theo Jansen, who makes these peculiar walking creatures on beaches. And I've been quite interested in this leg mechanism. So, we've got this little central crank which turns, which moves the legs. But the legs in particular are the part that bothered me, right? So we've got two legs on this guy. And what I wanted to be able to do was that I wanted to make them easier to assemble. So I wanted to basically try to have it so that there was as little assembly as possible that's needed for these legs. So one of the things that, based on what we were talking about last week, it got me a little bit inspired. And I started redesigning it so that each one of these legs, right? So basically, like everything that goes around the edge of this shape here, that's basically one leg that goes off on this side. It's a single print. So there's nothing that has to be snapped together. There's nothing that has to be joined. It just prints then and there, right there on the build plate. And in particular, we talked about having embedded joints, right? So we've got, for example, like a joint up the top here, which basically has an arm which goes into a single receiver here, and it pivots inside it, right? So another example is like, up the end here. But having a single arm which goes into a single, I guess if you like, crankshaft, works pretty well. But the thing that I had been wanting to do for ages, and I'd finally figured out, was to actually have it so that I don't know whether it's super clear here. I've actually got three embedded concentric circles here. So I've got 1, 2, 3 that are here, and that means that we've got 3 independently pivoting arms around a central pivot. And that was the really tricky thing, right? So previously, when I printed one of these out, that whole thing had to be assembled. And typically, what I had was that I had a couple of concentric arms and a sort of a snap-in pin, and that was prone to failure. It was kind of fiddly to make. And now what I can do is that I can crank out one of these legs. I mean, it's a fairly small print, and there's a lot of detail required, so it takes about an hour and a half to print. But it still takes less time than my original leg to print, because I've been a little bit more conservative about the material. And it's also, there's 0 time for assembly. You just pick this stuff straight off the build plate, and it just sort of works. So I'm sort of pretty excited about that, and I just want to sort of make a little pitch for sort of trying to design mechanisms that do print in place, because printing in place is one of those things that is really sort of like unique to 3D printing, and it's extremely hard to do, with any other process. And, if you are fiddling around with 3D printing, it's definitely one of those things that I'd encourage you to think about, like, in your design. Is this one of those things where, 3D printing could perhaps solve a little bit better than any other sort of like conventional process? So I was pretty excited about all of that, and I was, definitely excited about finishing this. So, now what I've got to do is that I got to work on a chassis so I can actually have several of these legs sort of like snap together into sort of a larger walking mechanism. That's another larger progress. So if I make any interesting progress with that, I will definitely share it with you folks. Totally. This one's a super, super, super tiny one. So I was actually looking at wind-up mechanisms for doing this, and while I'm here, actually, I found a wind-up mechanism for a little toy car that can also be completely 3D printed. And this is sort of like the power mechanism for it, and it's got a little sort of like wind-up crank. You can see it sort of snaps, and this is stuff again, stuff that sort of prints straight out. This one does require assembly, so it's actually got several pieces which fit together. But you can crank it, and it's even got a wind-up spring. So you can basically crank this up, and it'll spin. And there's several sort of like down gears that are normally down from this. I just wanted to print this out in isolation to see how it works. But you can totally sort of like build like powered mechanisms. So you could put like I mean basically like clockwork, right? So you can print out a spring. Yeah, you totally can. Though I don't know. I mean, like the interesting thing about using metal in a clock is that you don't get so many losses due to sort of like friction and heat. And I don't know whether the same would apply to plastic or not. But there it is, right? So I thought that was kind of cool as well. So I was kind of excited about that. So I wanted to see whether I can take this walking mechanism that I have and actually add a maybe a like a clockwork power to it, I guess. So that's kind of exciting, and that's kind of cool. So I'm gonna see how that goes. So that's that. Anyway, back to things. So okay, so just touch briefly on sort of like the care and feeding of 3D printers. And let's just say you've got a 3D printer and you brought it home. What do you need to do to keep it running? And I realized I hadn't sort of touched on this in enough detail in the past. So I wanted to sort of come back to this to make sure I'd covered this detail, because it is kind of important, right? So, you've decided you want to get a 3D printer. What do you need to do to keep it running, right? Same way that you bring home anything mechanical like a car, like what kind of maintenance do you need to do on it to sort of keep it running? And, 3D printers are pretty cool. They're fairly advanced, but to a certain degree, they are at a relatively early stage of development. And they do require a bit of mechanical attention. And, basically the more you pay for a printer, the less sort of like care you'll have to do with it, because they tend to come with features that make some of these things a little easier. But generally speaking, like, it's definitely worth paying attention to this, because when, even if you do get a fancy printer, even when it does go wrong, it's useful to know the kind of things that you need to be able to do to repair it, for example, right? So touching on some of these points just briefly, bed leveling, right? So when you are printing, it's really important, when you've got your nozzle, you've got to make sure that your print bed is pretty perpendicular to it, right? It's actually very important to have it perpendicular to it, because the tolerances in 3D printing are pretty small. So one of the things that you need to regularly do, sort of every like 4 or 5 prints, some manufacturers say you need to do this for every print, is what you've got to do is that you've got to make sure that the print bed itself is level compared to the print head. And generally the way this is done is there's a very quick trick that a lot of people use called the sort of the paper test. And what you do is that you move the nozzle to one corner of the plate and you slide a piece of paper under it, and then you adjust the height. So normally there's a little knob on the bottom of the plate that allows you to sort of adjust the height, or maybe even like a screw on the top. And what you do is that you adjust the height of the plate until the paper can just slide in between the print plate and the nozzle. You want it to sort of almost but not quite touch, right? And then what you do is that you go to the other corner, you do the same thing, and you repeat that trick on all 4 corners, and then you bring the print head right to the center, and then you try sliding a piece of paper under, and then you make little micro adjustments on those 4 corners until it's level. And that is time consuming. It probably takes about 5 to 6 minutes for most people. It's not a quick thing to do. And you can even sort of get fancier. What you can do is that you can print out test pieces. So you can print out, so you basically generate a shape where it will print out, say, like a little very thin square in each corner of the build plate, maybe only 1 or 2 layers thick. But then what you do is that you look at how it gets printed out. So if the nozzle is too close to the plate, basically you'll get little to no plastic that gets deposited on the plate. And if the bed is too low on a particular corner, what will happen is that the print will come out quite blobby, and it'll come out sort of like thick and sort of fairly malformed. So what you want to be able to do is that you want to be able to make sure when it prints, you get the same sort of uniform thickness for when you print out these simple shapes on the build plate. The more expensive printers will come with features for making that a lot easier, so they can do semi-automatic build leveling. So what they'll have is that they got a sensor in there, and what it will do is they will basically trace shapes around the size of the plate, but then it will detect how much sort of like tilt there is in the plate, and just ask you to sort of turn knobs on the corners of the plate until it's level. And some printers actually have little solenoids or little motors that can then actually automatically level the bed as well. Note that that's super fancy. That's, you know, you have to get a fairly expensive printer for that, but that's kind of nice as well. But the nice thing is that as these features get developed, they'll eventually get sort of pushed back to sort of cheaper and cheaper printers as well. So that's going to become more and more accessible over time. Another thing that you want to be able to do is that you do need to be able to keep your nozzle pretty clean. As you print, sort of, you know, the plastic's imperfect, things heat up the same way. The sort of like, you know, when you've got, for example, like an electric stove top and stuff gets burned onto the top, and you occasionally need to sort of like clean it out. No matter how careful you are with sort of like keeping it tidy, you know, you do want to sort of make sure that your nozzle stays pretty clean. You know, that can sometimes be done just with mechanical methods, where what you do is that you just heat it up to a certain temperature and you just feed filament through. But then you can also get, for example, like cleaning filament, which is this really sort of like slick nylon filament. And what it will do is that basically you just feed it through the nozzle manually, and that will just pick up a whole bunch of gunk as you feed it through, and that will help sort of keep things lubricated and clean as well. And the other thing I just want to mention, as far as sort of like, you know, regular maintenance goes, it is actually kind of useful to do a couple of prints, you know, like a print a week roughly, right? If you leave your printer sitting on its own for too long, it does quickly sort of like go out of calibration, just as sort of, you know, metal cools and expands and plastic cools and expands, and things sort of get a little bit creaky. Same as like, you know, a car that needs to be sort of like, you know, semi-regularly driven to make sure that the engine is still like, you know, still in reasonable condition. So what you want to do is that you do want to do the occasional small print, even if you're not planning to sort of do very much with it, just to sort of keep the mechanism running and just to keep everything sort of like calibrated, and so things don't get sort of too jammed up just because it's been sitting there. So yeah, there's that. Any questions about sort of like, you know, that? Awesome, cool, that's pretty there. That one I thought was pretty straightforward. Okay, let's talk a little bit about finishing prints. This I kind of enjoy, actually, because this is one of the most fun bits about making a print. Is when you actually get to sort of like polish it up and make it a sort of a real thing. So I'm going to switch back to my overhead camera for a little bit, so you can have a look at what's here on my desktop. So, you know, you do want to make sure that you've got like a reasonable set of tools with you for when you're finishing prints, right? So, you know, pretty standard set of things. You want to make sure you've got an X-Acto knife for basically trimming off any burrs that you get with your prints. That's a fairly common artifact, especially on the bottom of sort of like prints where you've got like high angles. You want to make sure that you've got, just in case you want to check the dimensionalities of things, check that you got a pair of calipers to see if you need to sort of trim anything exactly. These are useful to have. Again, these are like, you know, a cheap sort of like $5 pair of brass calipers that I found enormously useful. I use this all the time. So, you know, a simple pair of calipers is really useful for measuring things. But another thing that sort of I hadn't really mentioned before was sandpaper, right? So getting sandpaper of various grit, so, you know, going from sort of like coarse to like super fine. And like with anything, you know, when you've got a print and you really want to get a nice surface on it, like with a paint job, what you want to do is that you want to start with a coarse sandpaper, you know, really give it a sort of a quick go to sort of get a lot of the burrs out, and then you just sort of proceed on to sort of like finer and finer grades of sandpaper to really get a much nicer sort of like finish on an object. So I did this actually just before the class. We had a shower handle drop off one of the doors, right? So we've got this shower door that had no handle on it. That was a little bit of a problem. So, you know, we wanted to put some handles on it. And, you know, because of the orientation of the handles, the bottom of the handle, like, you know, the bit that you grip on with your fingers right at the back, that was really rough. So, you know, I had a quick go at it with a sandpaper. It took all of about 5 minutes to have a go at, like, you know, there's this little like 4 centimeter, you know, backside of this handle, just very quickly sort of like sanding it off, and then going from like, you know, 240 grit down to sort of like 3000 grit. I ended up with a very, very good but very quick result where it was nice and sort of smooth, and then, you know, reasonably comfortable to grip with your fingers, right? Because you don't want to, like, if you've got wet fingers coming out of the shower, you don't want to like cut your hands up on like a you know, a rough shower handle. So that was, you know, that was very quick to do. And as a first step in terms of finishing a print, it's something that I'd recommend that you do if, like, appearance or touch is something that you care about in the print. So, that's a relatively quick thing to do, and you get a lot of sort of bang for buck. But then when it comes to sort of finishing a print for painting, I'd definitely say that sanding is also very much worth doing, right? Because it helps prime a surface for printing, sorry, for painting, same way as sort of like painting any sort of like surface goes. So let's talk a little bit about sort of like, how would you approach that? And earlier on, I talked about sort of like, creating a 3D print of various sizes. So what you could do is that you understand the dimensionality of what you're printing, right? So you know that when you print an object of a certain size, it's going to come out a certain size, and you make a series of reference objects for a particular material. And I'd probably say that it's worth doing also in terms of, taking a reference object and then just finishing it in various ways. So you've got a reference for understanding, like, what are your options as far as finishing an object goes, right? So one of the things that I recommend doing is printing a fairly difficult sized object, right? So I just made this up in Tinkercad. There's really not a lot to it. It's just this sort of this weirdo shape, right? So I just made it up out of all these primitives. And one of the things I focused on was making sure that the bottom of the object was not great, actually, right? So I put in all these difficult angles and like this weird shelf, and you can see that on the bottom of this print here, this surface is sort of like fairly rough, right? So I can just tilt it in the light here. You can see that it's fairly rough compared to the top side of the object, which is relatively smooth, right? And you can see that, like, down the sides of the object, there's a little bit of striation here as well. And this is sort of this like, it's very tiny, but it's enough for me to sort of test with. So what I wanted to do was I wanted to see what various kinds of finish that I would be able to get with this. So, once I had this reference object, I tried finishing it in various ways to sort of demonstrate what was going on. So acrylic is very commonly used with 3D prints because acrylic is cheap. It's very vivid, and it binds sort of reasonably well to sort of plastic. So here's an example of what you get when you take that object and you just paint it straight with acrylic. And when you paint it straight with acrylic, it's okay. The paint's a little bit blobby, because that's just how acrylic is. It's a little bit sort of like goopy. And this is a single coat of acrylic which goes over it. You can see that the acrylic actually did a pretty good job of covering the sort of the color that was underneath, right? So I'd had this red color, and I intentionally chose green because I thought if there was any red, it'd sort of show through reasonably well. And you can see here that even though I had sanded the object, it still picked up a lot of the I guess sort of the imperfections on the surface, right? So you can still see that there's a lot of sort of like lines here on the bottom, and it didn't finish all that well, or it didn't finish as nicely as I would have liked, right? So that's what happens when you paint on it straight. But there is a thing that you can do where what you do is that you, like, like in normal painting, you can apply a primer to it. And one of the primers that I really like for finishing 3D print is this stuff called gesso. And it's this, or gesso, I'm not exactly sure how it's pronounced, but it's this gesso, there you go. And, artists use this to sort of prime canvas, right? So the paint can bite into the canvas a little bit. And this actually works really well with PLA, right? So what, gesso is a little bit goopy, and what it will do is that it will actually get into the cracks of the PLA and actually help smooth out the surface a little bit. Especially if you've got, like, the lines from the layers that are printed there. And what I'll do is that I will put down a couple of thin layers of gesso, just so it binds nicely, and I'll try to get it on as evenly as possible. But then what I do is that I sand the gesso right after that as well, right? And that really helps get a significantly smoother surface when we're doing that, right? And so, I started with the gesso, and then I tried a couple of different finishes here. So I took the gesso, and then I applied the acrylic straight on top of that. And here's what it looks like. Now, because it doesn't sink in quite as much as it does with the with painting straight on PLA, you can see that it does show through a little bit if you're not careful about making sure that you got an even coat. So this is a single coat of acrylic, but it does maintain that gloss look. and the finish is already significantly nicer in terms of smoothness, right? Because I was able to sand both the combination of the gesso and the PLA. I ended up with sort of a much smoother surface, and we ended up with a little bit of a sort of a better look. But note that because I was just storing this in a drawer, the actual paint itself isn't all that well protected. So you can see that there's already this tiny little chip has come out of the paint, and I was able to sort of take a little ding out of it there. So it isn't super well protected, but it does give you this nice sort of gloss look. But really, the thing to do after doing sort of a primer and an acrylic layer is to really add a varnish, right? So some people like the gloss varnish, they really like that look, but the thing that I am super fond of is actually taking this slightly toxic but really great matte polymer varnish, right? So you can get these matte varnishes, which I didn't even know existed. It's really nice, but you have to dilute it and use it somewhere reasonably well ventilated. But oh my god, it gives you such a nice finish, right? So this is what happens when you print. Sorry, when you paint with the when you basically add a varnish layer on top of it. And like anything, it's useful if you put down multiple thin layers rather than one thick one. So I did a couple of thin layers of the matte varnish here and just left it over time to dry. I give it a good sort of 12 hours to dry. And this ends up with a much more even, much more sort of flat look. It almost looks sort of rubbery. I'm super keen on that look. It's like the kind of look that you get with the Funko Pop dolls. But they look sort of super nice. And this gives me a nice sort of even flat finish. And I really quite liked it. But you can imagine that if you added sort of a gloss varnish here as well, you'd end up with a similar sort of look, but just shinier basically. And it's worth investing the time, like I said, in doing a couple of thin layers of acrylic and thin layers of primer and a couple of thin layers of varnish, and really does sort of do a lot to sort of elevate your print from sort of okay, here's this fun thing that I made, to something that's really sort of really quite polished. And since you can print anything dimensionally, it's really nice to sort of elevate your making from something that's sort of a little bit approximate to something that really is sort of nicely finished. I'm super fond of it. So this works really well for sort of finishing your various art prints as well, if you can get in and sand. There are other options though, right? So one of the things that you can do, and really what it comes down to is sort of trying to get out that layered look that you get from 3D printing. One of the things that you can do is, if you're printing with PLA, is that you can, is it PLA or ABS? I think both of them, they're a little bit, you can do this a little bit, is that you basically take your print and you place it inside a, typically an upside down bucket with something that's evaporating alcohol. And what'll happen is that alcohol will, I guess the gas will end up dissolving the surface of the print a little bit. But what it will do is that it will remove the striations, and you end up with a much smoother looking print. The downside of that is of course, everything it off gases with. I think ABS, it works fairly well for. PLA, not so much. But you do end up with a much smoother looking print. But the downside of that is that if you leave it for too long, even if you leave it running for a little while, it will get rid of a lot of the details you have in your print. And that's not so great, right? Because sometimes the whole reason you're 3D printing is to add little details and things. So it's a balance, right? In terms of do you use this method, or do you use other techniques to print your model? And that's why, touching on what we talked about last week, sometimes it's useful to print your model in pieces so you can finish each part of the piece separately, but also so you can access each piece separately and finish it. And then, for example, after you've glued it together, that's when you can sort of worry about the seams and deal with those separately, but you're still able to get to your individual parts of your model so you can finish it properly. So that's what all that is about. Okay. All right, let's touch briefly on 3D packages. So I think repeating what I mentioned in the first class was, there are sort of classic modeling approaches that you can take, right? Where, you've got, I guess they're classic at this point. When I started all of this, they really weren't, but many years ago. But like, you know, now sort of like, you know, you have these approaches where what you can do is you can sculpt in ZBrush or Blender or Medium, or you could use like, you know, Blender again or Maya to actually do like, you know, your hard surface models. And for creating artistic stuff, I think 3D packages are great. You can do mechanical stuff in Blender, and absolutely, like, and if it's something that you do day to day, if you're like, you know, if you're day to day modeling stuff in Maya, if you're day to day stuff modeling stuff in Blender, and you can manage the mechanics of what you're building in your head, I think it works pretty great, right? And they're a good way of sort of like, you know, putting whatever it is you want together. But, you know, I think in terms of actually making things that are mechanical, CAD packages are slightly better suited to doing that because you can do a lot more sort of like conventional things in terms of finishing it. But before I go on to CAD packages, I wanted to talk briefly about sort of like, you know, what are your in-between approaches? And what you can do is that you can take models that you have glued together. So for example, like in Tinkercad, and you know, Tinkercad is nice because it sort of like, it's a nice sort of like bridge in between sort of like, you know, your traditional sort of CAD approaches and your more sort of free form things like you know, like, so you've got like an art model, so you can like, you know, I mentioned like the kit bashing idea. But then what you can do is that you can take the output from those and put them into something like MeshLab and Meshmixer to really sort of like finish the model and maybe even transform it into something else. So let's have a look at sort of like what that looks like, right? So, you know, what I've got here is I've got like a really, really, really quick dumb model that I made, right? So it's basically a cone with a sphere that's attached, right? It doesn't really represent anything very much. It's just something abstract that I thought would be sort of like fun to work with. So what I'm going to do now is I'm going to open up MeshLab. So that's what this little piece of software here is. The user interface on it is kind of janky. Everything is sort of like very technical and not particularly well explained, but it's good enough to use, right? Especially if you know what you're looking for, and you know, half the reason I'm telling you about this is so you can know what you're looking for. And then what you do is that I'm going to take this little blobby model that I have, and I'm going to feed it straight into MeshLab. When it says unified duplicate vertices, definitely worth doing. It just sort of like makes your model a little bit easier to work with. And you can see what I've got here is that I've just got this little sort of like slightly offset sphere that's sitting on top of this cone, right? Nothing to write home about. But I'm going to start making this a little bit more interesting, and I'm going to do a little bit of artistic interpretation starting right here in MeshLab. So what you do is you go to the filter menu, and then you go to remeshing, simplification, and reconstruction. Already a little bit of a mouthful. And then what you do is, the one that I like using is, you can see that there's these couple of like simplification options here. I'm just going to pick this quadric edge collapse decimation because I like the results that it gives you basically. And what I'm going to do now is that you can see that what it will do is it'll pop up and it'll tell you that in this model, there are 1,048 like triangular faces that are here. And what I want to do is that I only want like 10% of those. So I'm going to make this model much, much, much simpler. So I'm just going to input a value of 100 and I'm just going to hit apply. And what that's done now is that it's taken the fairly detailed model and turned it into something that's kind of even blobbier. But it's kind of cool looking. It's kind of weird. Like, and if you like that low poly look, that's definitely it. But then what I'm going to do is I'm going to export the mesh. And when I do this, I need to remember to change the file format back to STL. Because by default, it'll be PLY. And I'm just going to call it, in fact, I already exported earlier today, so I'm just going to write over right at the top. I'm going to go blobby reduced. So I'm going to take that and I'm just going to replace it. And there we go, right? So that has now exported the model. So I'm going to get rid of MeshLab, and then we're going to go on to the next tool, which is Meshmixer. And Meshmixer is a lot of fun. So what I'm going to do now is I'm going to take my reduced blobby model, and I'm going to load it into Meshmixer. Now, Meshmixer is pretty nuts. There are a lot of things you can do for it. So if you just search for it on Google, or maybe I'll actually put a link to this in the description for the video whenever I publish it. But like, you know, you can download it fairly easily. It's a free download from Autodesk, and we can already do some fun things with it, right? So we can turn this into like the world's worst snowman. So you can just very easily sort of like sculpt this. Let's see if this is working. No? Okay, maybe not. Let's see, this is going to let me. There you go. So I can start, like, drawing on terrible arms. Come on. Is he going to let me? Oh, no, it's not working for me. Okay. I kind of put on this really sort of, like, weird arm there, but then, I can put on eyes and maybe, like, a nose. But, you can very sort of, like, quickly create sort of, like, whatever horrifying model you like. But I'm just going to undo some of those steps. There we go. And we're going to go back to the model as it is. Hold on. There we go. Okay. So, I've imported this model, and like I said, you can sculpt it. But the thing that I wanted to show you was this edit tool, which is super underrated, and it's kind of cool. So what you do is that you go to the edit tool, and you hit this thing called Make Pattern. And with Make Pattern, what you then do is that you switch to dual edges under the pattern type. And what it does is it gives you this, right? And what it's done is that it's converted the model into a sort of like a cage structure, which is super cool. And what's neat about this is that you can adjust the diameter of those pipes. So I wouldn't recommend going much below sort of like 1 millimeter, but you can make them sort of like pretty thin if you like. Most people stick with 2 millimeters because it's pretty good and it prints well. And most of these models that are set up this way should be able to print without any supports as well, right? So what I've done is that I've taken this fairly complex model and reduced a lot of the volume in it. And we can make these types of patterns sort of like fairly sophisticated. So for example, if we change it to mesh and Delaunay dual edges, what it will do is that it will also create sort of like an inside edge on this as well, right? So it's kind of neat, right? So you can create this sort of like fairly sophisticated models that are quite strong, right? And in fact, this what it's done is that it's added a little bit of structure on the inside of the model as well. And this is useful for cases where, so for example, like this is sometimes used in the design of prosthetics, where what you want to do is that you've got like two ends on like a limb, and what you want to do is that you want to connect the interior of the limb without using too much material, right? You want to keep it light. So by doing something like this, what you do is that you basically fill the inside with this sort of like there's almost like this organic looking grid, and what that will do is that will provide you a lot of strength without a lot of weight, right? So if I move this sort of like if I got the edge size about right, what this will do is that this will allow you to sort of like generate these fairly sophisticated objects. So that's what that is all about. So then what you might do is that you may have like a top end for it and a bottom end for it, and then you just import the middle into Meshmixer to sort of like turn it into one of these grids, and then you import the top and the bottom and you combine them and you print that instead. So this is another way of like in between finishing a model, right? So you've modeled it in another package like Tinkercad or Fusion 360, which I'm going to touch in a minute, but then you bring it into one of these packages to really sort of like turn it into something else, and then combine the result and you just print that. I thought it was really cool, and this this package is definitely worth sort of like fiddling around with. Oh boy. Sorry, it's having a little bit of a think. But then like you can take this model here and then you could try sort of like sculpting it if you really wanted to. I don't know whether this is even going to work. There you go. So you can start turning it into like really weird shapes, right? I'm not sure how printable that is now, but I've turned it into something sort of like fairly horrifying. So there you go. It's the world's scariest rabbit. So that's an idea, like for some of you to try out. I'd highly recommend sort of like grabbing this in a way of like really adding sort of like an artistic spin to what you're doing, into like turning something functional and using a tool like this to add sort of a little bit of character to it, basically, right? So there's that. Anyway, download Meshmixer, give it a try. Highly recommend. Okay. But then the thing that the thing beyond that is really sort of like talking about CAD and computer assisted design sort of processes, and they are a little bit formal, but they're definitely worth having a quick look at. And the nice thing about using a CAD package is that it definitely allows you for a much greater degree of polish that you get with say using Tinkercad. So let's just touch on that briefly, right, and like see what that looks like. And the example that while I'm waiting for this to load, I'll mention like the example that I want to be able to do here is I want to just make a little like C-shaped washer, and I want to add a little bit of polish to it. And I'm just going to go through a couple of different ways of doing that. And the thing to note with Fusion 360 is that it's really more sort of like it's, you know, with Tinkercad, what you're doing is that you're adding and removing objects, right? So you're adding and subtracting material. The way Fusion 360 works, and a lot of CAD packages work, really, you know, at the core of it, for the bulk of what you do in the package, it's really about starting with a simple shape and extruding along it, right? So what you do is you start with something flat, and then you turn it into a volume, and then you combine those together, right? And that's really sort of like, you know, where the start of it is. So, you know, here we are in the Fusion 360 workplace. I should note that this is another thing that is free for hobbyists to use. So I'm just using the hobbyist license here because, you know, I don't use this to make any money. You know, it's one of those things where it's a little bit hard to figure out how to get the hobbyist license, but you can totally do it. So again, like, you know, once you're ready for this, it's something that's relatively easy to do. So let's just create an object, right? So what I'm going to do is I'm going to start, and what you do is that you do this thing called a sketch, right? So what you do is you create a sketch. So I'm going to start with this down here. Now note that if you look in the top corner here, Z, remember, is coming up out of the build plate. So I make sure Z is sort of oriented upwards. And then what I'm going to do is I'm going to start here. And the specifications they're going to have for this washer is that it needs to go around 270 degrees. And it needs to be 10 millimeters on the inside diameter and 20 millimeters on the outside diameter. And I want it to be a little bit smoothed in places. So what I do is that now you know, this becomes much more sort of like, you know, your conventional 2D drawing tool when you're doing your sketch. So I'm just going to start with a circle, and I'm going to make sure that it has a 10 millimeter diameter here on the inside and a 20 millimeter diameter on the outside. And then what I'm going to do is that I'm just going to cut a corner out of it. So I'm just going to create a line, and then I'm just going to make that go from the center there. Oh, nope, that's not what I wanted to do. Sorry. Create a line, and then do that. So I'm just going to go from there to there, and then from there to there. And then what I'm going to do is I'm going to use the trim tool by hitting T to remove the bits that I don't need. So I'm just going to trim that out. And then trim out these inside bits, and there we go, right? So here's our basic washer. And what I want to do is that I want to make sure this washer is 5 millimeters thick as well. So it's kind of got like a nice square cross section. So all you do is you do extrude, like so, and that's it, right? So you've made your little washer shape, and that's relatively easy to do, right? So you can take this and you can make a quick object like that. But of course, like, you know, like any sort of sophisticated package, there's more than one way to do the same thing, unfortunately. So what I'm going to do is I'm going to show you yet another way of doing it. So I'm going to do the exact same object, and what I'm going to do is I'm going to take a revolving workflow instead. So remember, like I said about, you know, the diameter has to be 10 millimeters. So what I need to do is that I need to start 5 millimeters out, because the, you know, diameter of 10, which means it's got a radius of 5. And then what I do is that I draw the cross section here, like so. I'm just going to hit T to sort of trim this guideline that I don't need. And then what I'm going to do is I'm going to take that shape, and I'm going to select it, and then I'm going to go to revolve instead. And then what I do is that I select the axis that I wanted to revolve around, which is here. That is going all around right now, but I just changed the angle to 270 degrees, and then we're done, right? And then what I can do is, and this is where it sort of like really shines, right? What we can do now is that I can select these edges, and I can really sort of like refine them. So I'm just going to select all around, basically all the edges that are on this object. Oop, not that. And selection here is a little bit finicky. And then I'm going to do this thing called basically filleting and chamfering. And what that does is that it allows a really nice way to just basically just like, you know, give the edges a little bit of rounding and a little bit of polish. So I'm just going to put like a 1 millimeter chamfer on that. Sorry, a 1 millimeter fillet on that. And what that does now is that that's really sort of like, you know, polish that object up, and it's given it a nice sort of rounding on those edges. And that's actually really important when you're printing objects, right? So even if it's only, you know, when you're 3D printing, whenever you've got sort of like really hard edges on an object, that is actually prone to sort of like warping and distortion. So if dimensional accuracy is really important and you don't need a hard edge, adding a little bit of, like, even if it's very modest, and this here it's a little bit exaggerated, but even adding just a little bit of rounding means that it takes a lot of the mechanical pressure off that edge and a lot of the tension, and it actually does allow it to sort of print with a little bit less warping and a little bit less distortion. So, we can quickly sort of generate objects that are like this. And, there are all sorts of things that you can do with this, right? So I'm just going to show you, I'm actually going to go back to that walker that I'm currently working on, right? So this is the current iteration of this walker, and I'm just going to hide this part of it just for now. And I'm just going to show you, for example, like, this is not only can you extrude along sort of like, a circle, but you can also extrude along a line here as well. So I've got this little cross section here, which I extruded along this wavy little line here. And this is actually part of a crankshaft, right? So if I show you sort of like, where that, the context of this, that's actually like, the crankshaft that is driving this mechanism right in the middle here. And, again, I sort of designed this all, I designed this like completely in Fusion 360. When I had the chassis part here, I was able to take those inside diameters for basically for the crankshaft and the crank pins to go through, and I added just a little bit of rounding on them, just simply so it's easier to assemble, right? So if you got these hard edges, if you add a little bit of rounding to it, it's a little bit easier to sort of like thread it on to sort of like this wiggly crankshaft that I have. And I'm able to basically use not only are you able to sort of like, create objects, but you can also use them to sort of put holes in things as well, right? So I use this same crank pin that I have here to actually put a hole into this this disc here. I'm eventually going to connect it to a motor, right? And this is going to be the motor that's going to drive the sort of the wheel that's going around. Whether that motor is like, a spring or an actual external motor, I haven't figured out yet. But like, I use that crank pin to subtractively take out the center of this object here. So the crank pin will nicely slide into this, right? And I did a little bit of fiddling with those edges so that there's a little bit of a gap around it, right? So I don't remember, like, if it's exactly the same size, it's not going to fit. But if there's a little bit of a gap there, just a tiny one, it helps really sort of like, add a little bit of room for it to sort of fit comfortably. So, once you have this, you can sort of start assembling your objects together. I guess the sort of, the units of complexity in Fusion 360 is that you start off with bodies. So bodies are individual objects that are created from like, sketches that you can assemble them together. But then what happens is that you assemble individual bodies together into components, right? And components are made up of individual bodies, and they can move together, and you can actually do stuff with them, right? So I'm going to bring up another example, which is a transformer robot that I was doodling with ages ago. I think this is like a year ago at this point. But like, I've created this thing here, and each one of these pieces is actually made up of several pieces, which print all together as a single unit. But because they're components, I can actually start articulating the components, right? So what I can do is that I can take this back leg here, and I can do things like I can try driving this joint. So I can try driving this joint here basically to see what is the end result of this. And sometimes these joints have hierarchies, right? So I can take this one here. Hopefully I'm selecting the right one. Let's see how this looks. If I drive this one here, it'll drive everything that's downstream from it as well, right? Like that. So you can set up little like hierarchies between those. And I haven't done a lot of fiddling with it at this point, but you can actually do simulations of this as well. So you can simulate how it's going to unfold. You can simulate basically just to check, like, how big a range of motion do I have on this? And, is it going to block in unexpected ways? And I was able to discover some interesting problems with this model as I made it, because I discovered that some of my choices for how this all sort of goes together weren't so great. It was a nice way of sort of like, testing this ahead of time. So this is, and these kind of like, testing and simulation features are really sort of, the kinds of things that you find in higher and higher end sort of like CAD packages. And, it's fun being able to do this just as a hobbyist, right? So, but I can imagine, like, I can kind of understand why, people who you do this for like a day job would end up paying for this, right? Because there's a whole bunch of functionality here that is super useful. The learning curve for this is not pleasant. It's especially coming from something like Tinkercad. You find very quickly that the kind of things that you're used to doing very quickly in Tinkercad don't flow as naturally when you jump over to a much more complicated package like this. And I found myself watching a lot of YouTube tutorials, actually a lot of tutorials that Autodesk provided as well, just for wanting to do what I thought were like simple little things. But once you learn enough about it, like I don't know everything this package does, and it does a lot, right? But I've learned enough to have fun with this, and sort of like, it actually has become, instead of just being a CAD package, like, I can see with this transformer here, right? It's become a something that I can achieve creative expression in, right? Even though it's quite sophisticated, and even though it's you know fairly sort of, I was going to say, I don't think it's a high-end user thing as such. You've got even crazier packages with even harder UIs, amazingly. But, even for like, a medium difficulty package, you can still get quite creative with it, and you can still get quite expressive in it, right? So I use it for a lot of art stuff, surprisingly. And, there are certain jobs where, this wouldn't be appropriate. So if I needed to sculpt something, then I'd use Meshmix or ZBrush or whatever. But for a lot of the things that I want to do, this is surprisingly expressive, and I've had a lot of fun with it. And like, when you're ready for it, it's something that I would recommend if you do want to do more sophisticated modeling. If you do want to do more sophisticated models, basically for for your own work. So that's that. Okay. The next thing I had after this was, do I have any questions?
Um, yes, actually, back to finishing.
Hmm.
Um, I'm thinking of um, something in particular, an object that, like I said, it'd be like a costume piece, like
Sure.
supposed to be like a badge.
Hmm.
And the finished product would be maybe comprised of three different colors.
Hmm.
And let's say it's an oval, and then it has little square shapes or circle shape, and they're like buttons or something. Don't actually move, but they're raised.
Sure.
Um, would you? I'm trying to think of a couple of things. Would you want to either use different colored plastics to represent the different parts, and you're just going to put them together, or is it, I don't know, prohibitive is the right word. If some parts are so small that taping them off and trying to paint them wouldn't work, can you layer? Can you layer on a 3D print?
Yeah.
That how do you how
Right.
would you do?
Okay. So it all depends on how much time you have to finish this, right? So, and whether painting is really an option for you, right? So, okay, here's the first easiest option: is if you don't want to finish your print, and just taking stuff straight off the print bed is fine, and you just want to use the colors that you get. You can actually get printers, or you can send your printers off to prints. So you can send your prints off to printers that can print one or more colors, right? So you can select a couple of different colors, and you can actually have like a two color print that actually uses two different types of plastic with two different colors, and it will just print that for you, right? So you can have that right then and there, and it's done, right? And that
Oh,
will
so
print.
it prints it right where you need it to be. It's not like you have to join it together or
Right.
layer.
And that's what it will do, right? So when it splits up the model, it will print out a like, it will do all like, if your two colors were say blue and white, right? What it will
Yeah.
do is that on that particular layer, it will do all the white stuff, and then it will switch over to the blue print head. The white print head will park, and then the blue print head will print. It does
Oh,
slow things down quite a lot, but it's totally possible, right? So you can
yeah.
get, um, they're kind of expensive to get one for home. They're not ridiculously expensive either, but like, it's a more of a cost. But for example, if you're sending your stuff off to a printing service, that's a totally feasible thing. Now, if you're printing this at home, what you could do is you could split your model into different colors. And again, if you don't want to finish the bits, right? Or if you wanted a particular piece that you wanted to paint a particular color and you want to do it separately, you could split your model into pieces, and you could just have them so that they snap together, right? So when we talked last week about having the pins, or just having little slots, so you can take those pieces and just having them as little guides so when you put in you put on a blob of glue and then you just drop the piece in, right? Anything that you can do to sort of like make the alignment a little bit easier, again, you can totally do that, right? And then what you can do is that you can print all of one color, right? So let's just say your backplate for your badge. Again, I'm just going to go with a 2-color example, but it trivially extends to sort of like more colors if you want, right? But let's just say your backplate is white, and what you do is that you print all of the backplates, and then so you do them as sort of like one big run, and then you then switch to the next color, and all your accents are going to be blue, right? And all your accent parts that are going to drop in are going to be blue. So then what you do is that you switch over to the blue filament, and then you print out all the accents, right? This is obviously after you've prototyped this, right? You definitely want to prototype things, how you prototype is how you prototype, right? You could prototype it all in one color, and you want to check how it all, fits together. You don't want to check, the colors and stuff until a little bit later on. But in any case, like, when you're ready to sort of like, manufacture everything, you can just basically do all of one color and then do the next color. And then if you have those individual little pieces and some of them just need some accents, let's just say you've only got one piece on there that requires one other color, you may want to just print it blue and then just paint those individual ones, right? Because that's not much painting. It all depends on like, how much finish you want on the piece. If you've got little fiddly pieces and you want to get in there with a brush and you print it all as one big unit, sure, why not? But all again, it depends on like, how accessible it is and how, like if, for example, if it's underneath something else, then painting it is going to be really hard and you want to assemble it separately, right? So it all depends on like, also, how inconsistent is it going to look if you've got all plastic stuff and you've got one piece which is painted. It is going to stick out a little bit because that's going to look painted and the rest is all going to look like raw plastic, right? So it all depends on how much time you have to sort of like finish this and what you can do to sort of like really tie it all together. So you may find that, let's just say you print all your back plates and all your front parts and you paint them all separately, but then you varnish it after it's assembled. So there's various ways of like, splitting this all together. So, you may not necessarily want to varnish it while they're all separate, but then if you varnish it when it's all assembled, then that will also help sort of hold it all together as well. And it will help unify the look. That sort of makes sense.
Right. Yeah, that's good. Good thinking.
Awesome. Yeah, it's just, there are lots and literally there are lots of ways to slice this. I'm sorry, say again?
Experimentation.
Absolutely. Yeah. And it's definitely worth prototyping and seeing the right way to do this. And you may find that 3D printing may not necessarily be the best way of doing this, right? So you may find that, when we did, when I did a similar-ish project a few years ago where we were doing, and I think I mentioned this in one of the previous classes, like, we printed out these little hangers for an art show, basically, so that bits of art would go into these hangers that would go into the wall. And the hangers would have a little piece of text on the front. And we thought that 3D printing it would be easy. Really not. And in the end, we found that, for the level of detail that we wanted, making it out of laser cut acrylic was much better, right? And, we were able to achieve a much bigger volume and they were much easier to work with. So, we had these pieces of laser cut acrylic, but then we actually had it so that we'd cut holes in the acrylic so that we were able to create a little U shape, and we knew that the acrylic was between 2 and 3 millimeters thick. So we created like a little hole that was about 2 and a bit millimeters. The acrylic was 3 millimeters thick. So we created little slots that were also 3 millimeters thick, so that the little side piece of the U at the bottom would just slot into that, and then the front piece that had the text on it also had a little like teeth on it, so it'd slot into the bottom piece. But you could see that we were able to assemble it out of flat pieces. So you could imagine doing a similar approach with if you had your badge, you may want to sort of create the back plate for the badge out of just lots of these laser cut pieces of acrylic, and then you just glue on the you glue on the little details. Yeah. The thing to look out for with acrylic, though, is that if you're using super glue causes it to stain actually pretty easily, right? Which is pretty frustrating, actually. So we didn't discover that until a little bit later, so we had to sort of change our handling of it to be a little bit more careful. But even if you got like a little bit of super glue on your finger and you accidentally like brush it across one of the acrylic pieces, it leaves kind of like a fingerprint on it, which is not great, and it causes it to sort of like whiten and turn a weird color. So again, that's another thing that you maybe want to factor in as well. It's all just a matter of like prototyping and seeing what you work, and just it's just basically figure out, okay, it's taken me X hours to make one of these, so, and I've only got one printer, so it's going to take X times 20 hours to make X times 20 to make 20 of these, right? So really think about sort of like your approach for doing this, and understanding, okay, like I'm okay, my printer takes 4 hours to make one of these, so in a day I can make 6, but that means that you have to get up every 6 hours, even during the middle of the night, to change stuff off the print bed and go on to the next thing, and that's kind of miserable. So like, be realistic in terms of like understanding what is your if you're doing stuff for like a show, or you're doing stuff for costuming and you want to make lots of the same thing, just think about how many you want to make, and like how many spares that you want, and just sort of plan appropriately for that, and look beyond sort of like 3D printing is great and it can definitely get you out of a tight corner, but if, again, like I said, there's a certain threshold you reach where you realize that you need to make so much of a thing that another manufacturing approach might be a better idea.
Right. Right.
Cool. Awesome. Okay. Cool. Any other questions?
No, I learned a lot.
Fantastic. All right.
Thank you so much for offering this.
Of course. No, it was a good time. I really enjoyed it. It was nice to be able to share this with everyone. So, and I hope this is, I get this video posted, and hopefully it's a reference for you folks as well that you can look back onto. So,
yeah, I will. I will definitely keep the links and reference.